We've spent months watching 3I-ATLAS, tracking its journey, analyzing its composition, marveling at the fact that we're observing an object that formed around another star billions of years ago. But as it fades from view, heading back into the darkness between stars, one question lingers: when will the next one arrive? Welcome back. Since July, 3I-ATLAS has captivated astronomers worldwide, the third confirmed interstellar object ever detected in our solar system. But here's what most people don't realize. We have absolutely no idea when or if we'll see another one. And that uncertainty tells us something profound about our place in the cosmos. Let's look at the timeline. October 2017, the Pan-STARRS telescope in Hawaii detects an unusual object, fast, on a hyperbolic trajectory, coming from the direction of the constellation Lyra. They name it Oumuamua, Hawaiian for scout or messenger. It's unlike anything we've seen before. Elongated, tumbling, accelerating in ways that don't quite match our models. By the time we realize what it is, it's already leaving. We get a few weeks of observations, blurry images, spectral data, then it's gone, back into interstellar space. 2 years pass, August 2019, amateur astronomer Gennady Borisov, using a telescope he built himself in Crimea, spots another visitor. This one behaves more like we expect. It's clearly a comet, active, releasing gas and dust. We name it 2I Borisov. This time, we're ready. Multiple telescopes observe it for months. Hubble captures detailed images. We learn it's composed of materials similar to comets in our own solar system, but not identical. Then, like Oumuamua, it departs, accelerating back toward interstellar space. 6 more years pass. July 2025, the ATLAS telescope system detects 3I-ATLAS. And suddenly, we're doing it all over again. 3 interstellar objects, 3 discoveries, spanning 8 years. Oumuamua to Borisov, 2 years. Borisov to 3I-ATLAS, 6 years. That's not a pattern. That's statistical noise. We cannot predict when the next one will arrive because we don't know where they're coming from. We don't know how many are out there, and we can barely see the ones that pass close enough to detect. Think about what we're actually observing. Our solar system is roughly 28 billion kilometers across. If we measure to the outer edge of the Oort cloud, that's vast. But interstellar space? The distance to the nearest star, Proxima Centauri, is over 40 trillion kilometers. To put that in perspective, if our solar system were the size of a coin, the distance to the nearest star would be several kilometers. Interstellar objects are traveling through that emptiness, most of them in complete darkness, no nearby star to illuminate them, no activity, no coma, just cold, inert rock or ice drifting through the void. We only detect them when they enter our solar system, when sunlight makes them visible, and even then only if they're large enough, bright enough, and traveling on a trajectory that brings them reasonably close to Earth. How many are we missing? NASA and ESA scientists estimate, and this is an educated guess based on statistical models, that potentially hundreds of interstellar objects pass through our solar system every year. Hundreds, but most are too small, too dim, or traveling paths that take them through regions we're not watching closely. Oumuamua was only about 100 to 400 meters across. If it had passed just slightly farther from Earth, we might never have seen it. 2I Borisov was larger, maybe a kilometer wide, and it was actively releasing gas, making it easier to spot. 3I-ATLAS is somewhere between them in size. All 3 were discovered almost by accident. Automated surveys scanning the sky, algorithms flagging unusual objects, human astronomers following up within hours. It's a testament to our technology that we've found even these 3. So when will the next one arrive? The honest answer is we don't know. It could be next year, it could be a decade from now, it could be happening right now, and we're simply not looking in the right direction. But here's where it gets interesting. We're preparing. The European Space Agency is developing a mission called Comet Interceptor. It's scheduled to launch in 2029. And here's what makes it unique. It won't target a specific object. Instead, it will wait, parked at a gravitationally stable point in space called Lagrange Point 2, the same region where the James Webb Space Telescope orbits, and it will wait for astronomers to discover a suitable target. Ideally, that target would be a pristine comet from the outer solar system, a long-period comet making its first approach to the Sun. But if we're lucky, if timing aligns, Comet Interceptor could be redirected to visit an interstellar object, to fly alongside it, study it up close, capture images and data that we could never obtain from Earth. This would be humanity's first close encounter with a visitor from another star system, not just observing from millions of kilometers away, but actually being there. NASA is also upgrading its detection capabilities. The upcoming NEO Surveyor mission, launching in 2027, will use infrared sensors to detect objects that are too faint for visible light telescopes. It's primarily designed for planetary defense, scanning for asteroids that might threaten Earth. But it will also detect interstellar objects earlier than current systems, perhaps weeks or months before they reach perihelion, giving us more time to observe them. There's also talk of dedicated interstellar object detection networks, systems specifically designed to scan the sky for hyperbolic trajectories, to alert astronomers within hours of a potential discovery. Because here's the challenge we face: when we spot an interstellar visitor, we often have just weeks to months before it's too far away to study effectively. Oumuamua was detected on its way out. We had already missed its closest approach to the sun. 2I Borisov gave us more time, several months of observations. 3I-ATLAS, we caught early enough to plan coordinated campaigns, but we need to do better. The next interstellar visitor might arrive when we're ready for it, with missions on standby, with detection networks operating at full capacity, or it might slip past us entirely, unnoticed and unrecorded. A cosmic traveler passing through our neighborhood in the night, seen by no one. What we've learned from these three objects is humbling. The universe is not empty. Space between the stars is not barren. There are countless worlds out there, planets, moons, asteroids, comets, that have been ejected from their home systems, wandering, some for millions of years, some for billions. They carry stories, chemical signatures from alien star systems, clues about planetary formation under conditions we can only imagine, and occasionally, very occasionally, one of them passes close enough for us to see, to study, to wonder about. Will the next one arrive in 2026? 2035? We can't say, but we're watching. Every night, automated telescopes scan the sky. Algorithms analyze data. And somewhere out there, perhaps already crossing the outer reaches of our solar system, another visitor is approaching. Silent, cold, carrying secrets from a place we will never see. When it arrives, we'll be ready, or at least more ready than we were before, because every interstellar object we detect teaches us how to find the next one, how to study it more effectively, how to ask better questions. Until then, we wait and we watch the sky. Thank you for watching, and remember, the next interstellar messenger could be discovered tomorrow, or it might already be here, drifting unseen through the outer solar system, waiting for someone to notice. Until next time.